end, and it's going to be a bit of a challenge, I know, so I'll try and talk loudly. So what we've got here today is a number of soil profiles across the district, and how I'm hoping this runs is there's a lot of people here who are very knowledgeable about soils. So we've got Simon, we've got Dan, who's hiding. So I'd like this to be a bit of an interactive session, and people chime in and talk about soils and their experience and what they know, for the betterment of all. So, as I mentioned yesterday, Mackay district is very complex geologically, and as a result there's a lot of different soil types. And there's been an attempt over the decades to map out broadly the soil types across multiple districts, and that's been done for most of the coast. But what all of you would know is on your own properties there's massive variability over short distances. And it's about how you manage or how you handle that variability and what's important to you as a land manager. So we'll start off on these three soils here, because these are alluvial soils. Then we'll move over onto some hard rock soils and then Ken and Mary soils. So we'll start off there. So these soil types are fairly dominant in the district. So you've probably heard their names. So we've got kaolin, we've got some Pioneer, and a Victoria plain soil. So they're the three I'm going to talk about first. But the soils, as you can see, they're quite different. Like visually they're different. And if you were to actually start handling these soils, they actually are different down the profile as well. So this soil here, these are all come from cultivated paddocks, so you need to know that. So the top part of the soil will be quite disturbed through the cultivation process. But this soil here, if you can see it, and I do have, if you want to hand those around, there's not many, but it'll give you a bit of a summary of some of the attributes or characteristics of the soils. So maybe just hand them around once you've finished reading them. So we've got a light surface, so a surface that's perhaps a clay loam over a fairly clear or abrupt change to a clay. So as I mentioned yesterday, when looking at a soil, you're looking at things that are either too much, too little, whether it is to do with drainage, whether it is to do with plant available water content, and generally soil health. And when you look at this profile here, what can they see in the subsoil of this profile? Is it a bright colour? Is it a dull colour? Is it somewhere in between? Because remember, bright colours, reds and browns, indicate good drainage. The paler colours, your greyer, even perhaps some of your yellows, you're starting to get into some imperfect drainage. So this spectrum of well-drained to poorly drained. And that's an important attribute for knowing what you're going to do with your block. So anyone want to have a go at picking a colour? Is it a bit of a browny grey? Yeah. Yep. So it's not grey, but it's not brown. So it's probably in between. So what would that tell you about this soil? Is it a well-drained soil? Is water going to move through this really quickly, and is it going to dry up relatively quickly? Or is it something that might hold a bit of moisture for a while? Yeah, so exactly that. And if you look even more closely, there is some subtle mottling. Not a great deal of mottling, but there is some pale mottling throughout. So that's probably the most obvious feature here. In its natural state, this soil would have what we call a bleached layer just below the surface, and what that indicates is on this heavier subsoil, which starts here, by the way. So there is a sharp change from here to here. So if you only dig here to do your soil tests and miss this, then you're missing a big part of the picture. And similarly, if you're only getting chem here, you're missing a big part of the picture. You really need, if you're serious about understanding the way your soil's behaving, you really need an awareness or a knowledge at least to the top 50. If you can go deeper, even better. But you can tell a lot just by looking at the top half here. So just chemically, I remember we spoke about soil physical, chemical, biological. Chemistry-wise, this soil is actually pretty good up to about 80 centimetres. But around 80 centimetres, you can get an increase in exchangeable sodium. And we've got some dispersion tests over here in the muffin trays. And it's a really simple field test you can do to see how that soil might behave upon wetting. And effectively, the process of dispersion in your subsoil, what that does is it seals your soil. It can decrease the rate of permeability, which means it can increase some drainage issues. It also can be a chemical effect, so your plant roots may not want to explore below that layer. But what we do know about this soil is that for cane anyway, we often find cane roots well below a metre. So the acidicity in this instance is not enough to cause a problem. So you've got to be careful when you use these numbers. You know, when you see a number on a piece of paper, it doesn't necessarily, it's something that you take and you use with all the other information available to you to understand that soil. And lastly, I think another really simple test that most of you will be aware of is the soil pH test. And it's probably something you get done all the time. But again, a really simple way to do it. And as you can see on this soil, it's about pH 6 at the top 30 centimetres. But then from about 60 onwards, it's about pH 8, and even maybe a bit higher. And in this profile, we've even got calcium carbonate in the lower profile. So, these are, I think, the type of things that if you can, with an auger or an excavator, if you're wanting to try and understand your soil, it's worthwhile doing. Now, I'm guessing most people have heard of the word texturing, where you form up a bolus in your hand, and I know it's in your guide, and it's in lots of literature. You don't have to be an expert at it, but just wetting up a soil, forming a bolus in your hand, and making a decision. Is it sandy? Is it loamy? Or is it clayey? 3 categories. It's all you really need. It can tell you a lot too, because what we do know in terms of soil moisture holding capacity, anything that's about a clay upwards, you increase the amount of water that soil can hold. So it allows you to estimate the bucket or the size of the bucket very broadly for your soil type. Okay, any questions on this one before we move to a younger alluvial soil? So this is an older alluvial soil, quite common. Kaolin is its name, if you're familiar with the terminology. Quite high in the alluvial plain system. So there is a bit of a katina to the alluvial soils across the district, and this is one of the higher ones. So this is quaternary, so it's in that 1.8, but it would be 140,000 years. So it'd be the last, Pleistocene. So one thing to know about the alluvial soils also, and this is across the board, is it's a reflection of the geology that has been eroding over the thousands of years prior. So we know that geologically, the Mackay district and the Pioneer, for example, has been eroding andesites, basalts, sediments, so a whole range of geologies. So you're going to see some of these in the soil profile. Now, what is common in a lot of soils in the district I've been finding is this grit, this white grit. It's a feldspathic grit is what it is. It's just it's a mineral. So I'm guessing most people know what I'm talking about. It's a white, maybe less than 2 mil grit. That's just an artifact of weathering granite or granodiorite. It's very common in those more acid volcanics, or igneous, sorry. Any questions? Anyone? Simon?
I'll just make a quick comment about in relation to soil.
Your sample, yeah, absolutely. Okay, so now this, these 2 soil types are found mostly on levees of the Pioneer and Sandy Creek. So lots of, this is a levee of a major river system. Okay, let's just say that. Now these are both Pioneer type soils. So, but they're very different. Slightly different. So as you can see, we've got a surface that's brown, some organic matter. Then you've got a yellow-brown subsoil. This one's more or less the same in the surface, but then you're moving towards a reddish-brown. Now, what does that tell you straight away? Which soil might have slightly better drainage? Which soil might be a bit higher in the landscape? The red or the brown? The red, exactly. And that's exactly what we found. So this was out up at Pinevale, and this was near Marion. So so this was definitely elevated, more elevated than the brown. Both very good soils, very rich soils. So the other thing you might be able to see here that's very, very obvious is the structure. So if you were to get a bit closer, you could see that there's actually quite good structure in this subsoil. And what that does is increase the amount of moisture that soil can hold. And it also creates more avenue for roots to explore. This is another texture contrast soil. So those texture or duplex, you might have heard them called, where you get a light surface immediately over a heavier surface. Both of those are like this. If I was to texture these with my hand, it would be, this is quite light, so probably a sandy loam. This one, maybe a little bit heavier, but perhaps sandy loam. So we're thinking maybe 15% clay content. If I was to texture immediately below this A horizon or this surface soil, we're going to get up to about 35-40% clay content. So quite significant increase. This one's actually a bit lighter in the subsoil. I don't know if you want to hand these around, if people want them. Thanks. Okay, fertility-wise, given that it's younger alluvium, tends to be more fertile. Those sediments that have been deposited through overbank flow are quite fertile rich. These generally have no constraints in the subsoil for any chemical constraints. In fact, they generally have no physical constraints either. One thing that can happen with these soils, though, is compaction and a lot of soils. And what we often find is at about 30 to 40 centimetres, particularly if you've got a clay soil, you'll see this band of about 10-15 centimetres of structureless clay. And it's normally around about there. And then straight underneath it, structure then is obvious. And that's an issue that everyone faces if that have traffic on their farms. Luckily for these soil types, that they've got chemistry on their side. So with good management, it's something that possibly can be overcome, but not ideal. Simon, Daniel.
So it's good to pretty much go back and try and remember the soils map that Mark was showing us yesterday on the screen. So despite of these two cores having been taken from a pioneer soil type, you can see the variability in there. So as Mark just highlighted, they are slightly different. But that takes us back to what Simon just said. When you find yourself out there in the paddock taking a core or digging a pit, you might find that, how far away were these cores from each other?
Marion and Pinevale.
Okay, pretty far away from each other. But in saying that, we've seen in the region very high intrapaddock variability. So when you go and you take a core in your paddock, when you go around, you can find pretty much like this happening and all that. So that's another thing we wanted to highlight with this, that despite of the soil map telling you you've got a pioneer soil type, you just got to make sure that you understand that intrapaddock variability and across farm or within farm variability, and try and, as Simon said, sample accordingly, so then you can manage accordingly. So I think that's, yeah.
Anyone else want to say anything? Any comments?
But how are you defining structure?
Yeah. So if I had a massive soil here, you would really quite easily see it. But structure is it's when you pick up a clod or a ped or an aggregate and you apply small force, it will break. Not break where you apply the force, but apply alongside natural weaknesses between aggregates. So, and there's lots of different types of structure. There's coarse structure, there's fine structure, there's different shape structure, which is somewhat irrelevant. But in these soils here, you can probably see it really clearly down here. If you were to pick up this, and I'd suggest if people want to, they can have a play with this later. But if I apply force to this, it breaks. Doesn't break necessarily where I apply the force, but it breaks against natural lines of weakness. And often what you might find is where that natural line of weakness is, you'll see some fine roots. And you also might see some mottling, because this is where water is moving. And where water is moving, you get this movement of iron, and you can get some discoloration. But yeah, so that's what I'm talking about. In cultivated landscapes, the structure tends to be quite degraded. You might see it, it's visible here, but often if it's recently ploughed and there hasn't been much time for the soil and the critters in the soil and the organic matter to do its job, you'll find it quite massive and sometimes quite hard setting.
To what extent does the particle size affect structure?
Yeah, so on the very lighter sides of your soil, so if you're dominated by sand, you're less likely to get structure. So, you start to see structure from your loams upwards. Yeah, and it all comes down to also mineralogy. So in a basalt landscape, for example, you almost will always see structure, because the clay minerals that are formed from the basalt parent material are such that they have a little bit of shrink swell in them, so there's this movement of soil, you'll get some structure. But in like a sandstone derived landscape, there's a chance that you may not get that structure. But again, parent material, the mineral of the soils, you've probably heard of kaolinite and montmorillonite, all those type of things, also are a driver. Yeah, sure.
In terms of deep ripping, is there a sort of like, if you deep rip that, would it benefit the top layer? Like, for example, if you deep rip that, are you wasting time? Your soil can look the same all the way along. Are you wasting time if you keep ripping? I'll tell you what,
Yeah.
my father sends me out to the pancake and goes, deep rip this, and I said, why? And he goes, because it's what we've always done. Yeah, always done.
Yeah.
So, if you deep rip something like that, are you bringing anything good from down deep up to the surface, or am I wasting my time?
And that's kind of the question as well. Like, what could you be bringing up is a good question. So in texture contrast soils, where you might have a top of the subsoil that is a little bit nasty, in this district they're not that common that I've seen anyway, and there's probably areas that are. But I know there's many landscapes that you don't touch the topsoil, because if you touch the topsoil and expose some of the subsoil, you open yourself up to rilling, gulling, tunnel erosion, etc. But yeah, I don't know the answer to your question, to be honest. Ripping has its purpose, I suppose, to open things up, but in doing so, you're also smashing, obliterating the existing structure. You're disturbing the organic biology of the surface, and we do know, I think Daniel mentioned it yesterday, that sometimes by doing some of these things you set yourself back. But I also recognise that when you change a management strategy, that is take deep ripping out of your management practice suite, that it can take time for a benefit or a gain to be seen with what you do. But so anyone, I'm sure there'd be other people.
With your deep ripping, it really comes back to what soil type you've got. So if you're stuck with some of that high sodic soils, and you're ripping them, you're probably wasting your time, simply because they what's the correct term? Sorry.
No, they're gonna close up and tighten again.
Yeah, so dispersive that the first rain or irrigation you get, that ripple line will be closed again immediately. So it's only open while you're basically in the paddock, and almost immediately it's closed again. So you've burnt a whole heap of diesel for no reason. In something like these soils, you can probably get a benefit, particularly in a cane paddock situation, because you're alleviating the compaction caused by heavy machinery. And you probably need to do that simply to get some water infiltration. So my problem, I have both of these soils, but mostly this one on my farm on the river. And if I didn't rip, my problem was that I could put on 25 mils and it'll be running out the end. It's gone. I couldn't get it to soak in. So, but instead of ripping the centre, what I ended up doing was ripping the two outside. So ripping on the edge of the wheel track on either side, and trying to get some fracturing underneath rather than ripping the centre. So I found that was more beneficial for me. But then the same thing happens even in those soils. They still, with irrigation and rainfall, they still close up again. So you need to keep it open. And the only way to keep it open long term is with roots. So that's the idea then of actually planting something there to maintain that opening for at least a period of time. Another point I wanted to make about soil sampling is going back to texture. So if you're mixing this stuff with this stuff inadvertently, sort of thing, because you don't know exactly where that line is, so you get those two mixed together and send that to the lab. They're going to do a texture analysis on it, and they're going to give you a texture that's not either or either, so to speak. And some of your benchmarks are based on your soil texture. So all of a sudden, you'll be looking at the wrong benchmark, and that can be a real issue. So yeah, it's imperative when you're soil sampling not to mix those two, to know where the break is, if there is one, and to sample them differently. Soil sampling is cheap compared to mixing them up. Because you mix those two, the result won't mean a thing.
Do you recommend particle size analysis?
Not when we're growing cane. I don't think you need to go that far. For something like sugarcane, C4, perennial grass species, if you're in horticulture, high value, yeah. But yeah, not so much for sugarcane or beef cattle.
I've been sort of including the particle size analysis to try and understand better with some of the soil-specific guidelines for the region and the soils maps, you know, to try and understand how big that bucket is, to try and understand the plant available water capacity of the soil and all that. And I sort of found out that it helps. And maybe going back to you, that question of yours can take us back to understanding the landscape as well. Maybe your water table is going to dictate whether you deep rip and you get a good effect or not. If the water table is shallow and it's bringing up stuff that you don't want, maybe by deep ripping, you might find yourself in a situation like the one we have at Mary Ann, that, as Simon pointed out, you go deep rip, but as soon as you're off the paddock, it's going to tighten up again. Or you might end up having a shallow water table that when you go and rip, you might be bringing up salts or stuff that you don't want. We've seen that with laser leveling, bringing up stuff that you just don't want to have a nice and even paddock. So those trade-offs, those things, you gotta balance them. And I know the old man can be a bit stubborn, but look, it's a step by step, and I think I highlighted that yesterday, I think at the end of the presentation. You can't make the old man change from, you know, deep ripping to minimum till. But if you start explaining all these things and maybe, you know, taking a soil core, or just say to the old man, hey, Dad, let's go and dig a pit, you know, and jump in there and get the pH kit and, you know, do a sort of pH difference or test in the topsoil and the subsoil. And you say, hey, Dad, look, if we end up deep ripping, we might be bringing some of this stuff up here, and that's going to compromise the ability of our plants. Or what do you guys grow cane? Yeah. That stuff is gonna, you know, mess up with our pH, and when you mess up with the pH and then you go on to galaxy mode and you remember Daniel Gonzalez and you start explaining all that stuff, and but it does make sense, and it's a sort of a steps integrated approach to try and understand all these things. But yeah.
One of the old theories that people used to have, and I noticed that the disc plough is making a comeback at different times. I don't own one, so I won't use one. But the old theory was they'd try and plough up some of the top of the clay and mix it with the topsoil so that you had... It's a bit like the deep ripping theory. I think it's a good excuse to sell diesel and tractors.
Getting it under the plow and yes, bringing a bit of clay to the topsoil so we can hold more moisture, and, the CEC and improve all that stuff. But
It does depend on your soil type and knowing what that is and how it affects. Western Australia, there's large areas of southern part of Western Australia around Esperance where they've got a thing called a non-wetting sand on the surface, and it's literally that. It's really sandy on the surface, and for us blokes, when we're out there and take a pee sort of thing, you've got to be careful because it's running everywhere, you're going to get your boots wet sort of thing. It just hits and runs. And what they've found is that there's a clay layer not far down, and they've been able to successfully these days turn that clay layer back over and make that sand on top much more water friendly. And they're also increasing their CEC, so that it helps with nutrient holding capacity, and it's actually a very beneficial thing for them. But at the same time, there's plenty of places in the same area that can't do that, simply because there's actually a toxic boron level it varies, but a lot of places it's down at 1 metre, but some places it's as close as 300, 200 mils to the top. And if they actually plough and bring some of that toxic boron to the surface, they've just ruined their soil for a hell of a long time, or a really big financial hit. So you really need to do some soil sampling, dig a pit in your different soil types, get an idea of where the different levels of your soil and your clays are, and then sample accordingly to that.
But what about long term?
Yeah.
It's quite well known the shifting of soil through disturbance creates different pathways for roots and different access to nutrients because you're shifting things around. Plant, yeah. Yep. No, good point. Okay, so we'll move to these two soils here, and then we'll talk about Ken and Mary's soils last, so we won't spend too long on here. So sorry if everyone's supposed to shift down. Now these two soils, well, we'll do them at the same time. So these are both cracking clay soils. So what we mean by cracking clay, no doubt everyone knows. So Victoria Plains, Brightly soil types in the district are the two most dominant, I think. So when they dry, they crack at the surface. They're normally clay at the surface all the way down. The Victoria Plains, which are in the lower parts of the alluvium, so like back plains, are normally black, grey at depth. The Brightly tends to be more grey at depth, so that's the major difference. But essentially these are just uniform soils, and particularly in relation to clay content and texture. In terms of colour, I've seen every time I dig a hole in one of these cracking clays, they're different. So where the grey comes in, it can be at different depths. The amount of mottling that you might occur in the lower subsoil is either there or not. So very variable. But soil moisture holding capacity, what do you reckon? Low or high? Yeah, pretty good. Yep. What about fertility? Yeah, pretty good. What about drainage? Has anyone got these soil types on their blocks? Yeah. what can you tell us about it? How does it behave?
Well, the biggest thing I'll tell you about that soil, Dad's got a lot of what we call glue pot soils. No point in deep ripping them because they self-alleviate. A soil that cracks successfully, so it cracks so that you can put your finger in it or your hand in it, there's no point in ripping it. You just need to let it dry out a little bit and it'll self-alleviate. So you're wasting diesel if you've got a self-cracking clay. It's also, they're commonly also called Sunday soils because you can only actually till them on Sunday because Saturday they're too flaming wet and Sunday they're too flaming, or Monday they're too dry. So yeah, difficult to work because you've got to get them at the right moisture content to actually successfully till them without turning them into clods or turn them into dust. So yeah, they're a challenge, but like I say, deep ripping is worthless because at some point it will self-alleviate. You don't need to. Yeah. Yeah. The previous owner of the block that Dad's got used to commonly cultivate a plant cone block 14 times before he'd plant it. So he's always out there too early when it was too wet. And it had turned into cricket balls, literally cricket balls. And they were as hard as a cricket ball, harder.
Is it sticky when it's wet?
Yeah, very.
So these soils are probably one of the most resilient soils because they have good buffering capacity. They're usually high cation exchange capacity, which manages to balance the pH better than those with a low cation exchange capacity. As Simon said, they shrink swell, so they're resilient in that nature too to counteract compaction and other disturbances. So they're quite a resilient soil. However, if you are to degrade them, they can actually be really difficult to bring them back up to a healthy form. So you have time to degrade these, but it'll take you a hell of a long time to bring them back up. So it's good to manage these well. So this is also a cracking clay soil, but this isn't on alluvium, this is on andesite. So this was out near Marion as well. And as you can see here, at about 60 centimetres, you're starting to get into a bit of weathering rock, and you're into weathering rock at about 70, 80, 90 centimetres, so rock proper. So yeah, so you can get similar soil types that shrink, swell, crack on different lithologies, different parent materials, so alluvial, hard rock. So you can see with this one here, your bucket size of how much moisture your profile will hold will be less, so soil depth is important. With this soil here, because it's an andesite-derived soil, you get extra minerals in it. So this one here has manganese. I think it's got some manganese segregations. You can see these little black dots through the or nodules through the profile. Again, we talk about this shrink swell. Here's evidence of that shrink swell. So you get these shiny faces where the PEDs are moving up against each other and create these lenses. So if you see these in your soil profile or in your pit that you excavate, you know you've got a soil that is a shrink swell soil. And sometimes you might not see the expression at the surface, you'll see it in the subsoil. So you can get these soils that don't have cracking at the surface, yet the subsoils are shrink swell. So it's a good thing to know. Don't know if you want to pass that around. So yeah, anyone got these cracking clays on hard rock? Yep. No. Yeah, no, it's more your texture contrast. So what's your clay surface? What's your surface like? Is it? So just got lots of micro relief. Yeah. 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 So these, what's the spacing of these? Yeah. Deep. Yeah, okay. I haven't seen any of those in this district. Whereabouts are you? I've seen gilgai, but they're normally, you know, might be 30 centimetres deep and about 5 metres diameter, but often have been... Yeah. Yep. Yeah, so I might get you to start off, eh? You can talk about what you've done.
I didn't do much.
Okay, so we've got the jackfruit.
Jackfruit, Wagura.
Yep.
Okay.
We've got the last soil of the day, so up where his mangoes were good. But then we got this one was
Wallingford.
Yep. One right behind us,
Wallingford.
and this one goes back over here.
Do we have a micro? All right, guys. So here, thanks to Dan and Mark, we actually were able to grab some samples. So let's go back in time again and let's try and remember what Mark showed us yesterday with the soils map. So we identified that through the farm we have mainly two soil types, which are Wallingford. Which one is Wallingford again? The one inside? Okay, Wallingford and Wagura. So that's the soil type names. I actually sent some samples to the lab that we're gonna go through with Ken and Mary later on from the topsoil to try and understand what's happening in there. But then we had Mark and Dan yesterday help us grabbing the cores to try and understand down to a meter or as deep as we could go to sort of what was happening in there and how the soil types would perform. So we have Wallingford in here. We just grabbed it from that witch hut down there. And Wallingford soil types are normally imperfectly drained and not very good at letting water permeate and filter down. Whereas Wagura are actually deep and well drained and with a very high plant available water capacity. So we were sort of trying to identify those characteristics, try and show Ken and Mary. As I understand, I don't think they had ever seen the subsoil and actually, you know, cast an eye on it and understand from experts like Mark and Dan to see what's going on in there. So hopefully in the near future, we'll keep investigating them deeper. And look, having identified where the changes are, as Simon suggested before, we could now conclude, look, from that spot, we can go and sample from the topsoil and maybe down from 50 to 60, we might go and grab another sample and try and understand better what's happening, depending on what they wanted to do on that paddock, and same with this paddock. Then, I think Reef Catchments built a case study with Ken and Mary a couple of years ago, and when I was reading that case study before we put together the field day and the symposium, I noticed that Ken referred to Block B, or back Block B, and he referred to a very drastic change in the soil type. And when we started talking about that paddock, he mentioned there was an area where the trees were performing and an area where the trees were not. So I thought it was a really good idea to, you know, go and take some cores from those spots, and, you know, having Dan and Mark here try and study and understand further what was happening in there and maybe what could have been driving that variability in the trees. I think those are the two ones we grabbed from that area. So if I'm not wrong, and Mark can correct me if I'm wrong, this one is from where the area, or from the area where the trees are performing well. And this one is just maybe 50 meters down where the trees are not performing that well. And look, first things first, we might have a look and maybe discuss the walling for the Wagura and the walling for a little bit further with Mark and Dan and see what these guys can actually tell us with regards to physical properties and what was the word that we used before that I asked Simon about the particle size? The texture, yeah. So maybe the guys can tell us and explain to us a little bit more about that. And then we jump on to those two from Back Block B and try and understand the issues that are maybe happening on that topsoil. If you compare those two, the area where the trees are performing and the area where the trees are not performing, have a look at the topsoil, and we'll have that discussion after we finish with these two. But yeah, I think I'll leave it to Mark and Dan. Where's Dan? Dan's hiding again anyway. Thanks, Mark.
Thanks, Dan. Okay, so I'm actually not getting. So we'll start with this one here. So this is the Wallingford at the Witch's Hat just here, where it's been mowed. There's a few things you can see here, quite obviously. Again, another one of these texture contrast soils where you're getting in this case, a clay loam with a lot of fine sand in it to a medium clay. So again, 30% clay to something's about 40% clay. But can you see this paleness here? These what we call them bleached layers, and they're often they're quite common across soils where there is an increase in clay content, because what happens when water moves through this profile, it moves quite readily through this top bit, but as soon as it hits this heavier clay content, it slows right down. And in the process of slowing down, you then get lateral flow, especially where you've got slope, and you get this leaching of mineral out of the soil. So you get this real paleness. So this is actually it has not much value in it in terms of a plant. And sometimes what you can see, if there's a bit of nastiness to this top of the soil, you'll see roots actually travel horizontally along the top of the subsoil. In this instance, we don't see that. We actually see evidence of roots most of the way down. We haven't got any chemistry in the subsoil, but in terms of the surface soil, it was pretty inert. There was nothing terribly alarming. We did some field dispersions. You remember where I stuck a ped in the water over there and we watch it react? Does it stay stable or does it disperse and you get clay particles in solution? These didn't disperse. However, when I did a texture on these soils in the lower soil, it was very soapy. So sometimes when you pick up some clay, you wet it and texture it to get a bolus. When you get a really soapy feel to it, really slimy, slippery, it's another indication that there could be something going on. But until we get some chemistry on this subsoil, we won't know for sure. You can see some pale colours, you can see some mottles. So about 50% of this soil is brown, yellow. The other 50%, 40% is grey. So you know that permeability is not moderately well. So you're down the path towards poorer. I wouldn't say it's poorly drained. So I'm thinking maybe imperfect, so in between. Otherwise, you wouldn't get those colours forming. And in this instance, as you can see, we're hitting weathering rock at about 90 metre. But again, roots, we have evidence of roots a fair way down. One thing Ken did tell us about this block is he's collected rocks over the years, and he's got a rock pile down off the edge of the paddock. Most of the rocks we saw were of volcanic origin, so these darker mineral andesites, perhaps. but Ken has found other sedimentary rocks in this block as well. And what we do know about the Campuin beds, which is the geology that surrounds these landscapes, is that they are interbedded geology. So in times of, we're talking millions of years, in the Permian, there were flows of lava. Then there was times of stability, and you had erosion and sedimentation. So you get a sedimentary layer, then you get more volcanics. So you get this interbedded relationship. So that's why it's not uncommon to get these mixed sediments, volcanic landscapes, and it makes it very complicated to understand soils in those landscapes, because over the time those geologies are now tilted like this. So each of these strata are almost vertical. So you might have mudstone, then volcanics, and then you might have a sandstone and volcanics over 50 metres, 100 metres. There's some soils we've seen in the Burnett district where you can actually walk across the layer between one geology and another. It's quite remarkable.
If we're all ready to go.
Okay, I'm going to be super fast. It's very wet. I'm wet. Almost time to go home. Got to pack up yet in the rain. That'll be good. I just wanted to tie a few things together. So we've done a lot over the last couple of days, obviously around variability and linking the variability to the soil. We've had fantastic talks on the soil, and we've had fantastic talks on how the weeds are indicating certain things that are going on with our farming practice and where we are in that successional path. I want to bring the drone side of it in, which I did part of in my talk during yesterday, but as a tool to help us recognise that variability and then be able to act on those different parts. You may recall yesterday I mentioned that we've already got certain ways of being able to know in advance where variability is on our farms. We've got our soil maps, EMI mapping, these types of things. We can walk around. We can look at the existing vegetation on the farm. We can look at the old mapping to see what the vegetation was across the farm, telling us what the growing conditions were suiting at different times. The one I mainly use it for, of course, now is using the crop as the indicator. So to me, we put a crop out across a block. It's probably been there for decades. The crop itself is that sort of indicator strip that's telling me those different growing zones. So if I'm going to go out into the paddock, take a soil sample, do any sort of investigations, a starting point for me is to use the crop to tell me what's going on. So for me, if I've got 5 different soil types going across my farm or going across one block, but the crop's happy across it, I don't care. Things are going well. I still might want to find out, could I get more out of it? But basically, the ground's doing its job, the organisms within that ground are doing their jobs, and I'm getting the crop that I want to get off it. I use the crop to find those patches that are not doing well, the poor performing parts. And the good thing about using the crop as the indicator is that it's only worried about one thing, and that's its localised growing conditions. So a lot of that mystique of other things that might do something and might not do something is taken away. It also could be something along the lines of the hydrology, disease, pests, which may not be picked up in the soil testing side of things. In that yield constraints identification mitigation trial that I've got going, the soil test per se shows that the poorer, freer draining parts of the farm are actually slightly better than the poorer draining parts of the farm that actually produce more cane. So if I just went by the soil test, I'd be making a mistake. It's the soil structure in the case of those trials that is the really big difference. So what I really want to say is that using your crop, you can do it walking around, having a look around. Most people on their tractors can identify some parts of that variability. The drone technology, and to some extent the satellite technology, is a great way of getting that big overview. You can do the whole block, you can do it multiple times, and you can find those zones. We can bring in the weed side of it. If I get to an area that's really high weed population, it's probably going to come back to poor yield in the cane or some prior weed infestation of that zone or some other process that's going on. On the drone side of it, it's really, really easy to do, the drones these days. It's a fully mature technology, so for $2,500, $3,000 you can buy a simple mapping drone. It's the same as those selfie drones that you fly around. It's not the smallest ones, it's the next size up. And the software is all automated, so the drone takes off, flies your paddock, flies a grid, and then in most cases the easiest way to do it for growers is to just upload it to the cloud, pay a subscription, it'll all be stitched, and you'll get back your maps that you can utilise, the information that you need to be able to go out, whether it's straight visually or looking at the zones of difference to work out the areas that you're concerned about. Most of you, I guess, are running legume or green manure fallows. I guess some of you are growing legumes and actually harvesting them. Works fantastic on all of those even crops, or what should be even canopy crops. You get a really good result. Tree crops is a little bit more challenging because you've got a lot of variability within the tree canopy. You've got different times that they might flush, flower, so there's a bit of difference going on there. But when it comes to anything that you're covering the landscape with as an even crop, you'll be able to see those areas of difference really quickly. And just to finish on, the spray drone, which is out there in the rain, luckily it's waterproof. It's like this much of drone technology. This much of it is mapping. Mapping is the real game. Map your farms, know what you've got. You can map it multiple times. You can compare it to last year. You can compare it to the dry years, the wet years, to the change of practice. Am I moving from a really weedy state through to a cleaner state? If I use cane farm technology, all those things are not only recorded at the time, but they're archived. You've got that record, you've got that previous map of the block from last year, the years before that are going on. So when it comes to the spraying side of it, I realise a lot of people are sort of less interested in the chemical side of it if they can. I am too. But when it comes to putting out chemicals with the spray drone, it's a really efficient and really focused way of doing it. So in particular, I use it on vine in sugarcane, so an out-of-hand cane or in plant cane that's got vine in it. I map it. First off, the grower knows whether he's even got a vine problem, whether he needs to do something. If the vine problem is too big, he'll get a manned aircraft in and fly it anyway and spray the whole block. But where it works really well is that the spray drone can go out and just target the patches, can identify where that, through the mapping beforehand, identify where it is, I map it out, and the drone simply goes out and puts the herbicide directly onto that. It also puts out solids, beneficial insects, beneficial other products. It can put out liquid fertiliser, it can put out granular fertiliser. So there's a range of things that the spray drones do, but what they can't do is carry a lot of weight. So if you've got 20 hectares that you're trying to put out liquid fertiliser on, that's not an option. You're going to be always doing ground-based gear. But if you've got smaller areas, more precision, then the spray drone is something that you can use. Now, I just want to ask, out of the crowd here, who's got a drone that they're using for mapping? Okay. And can I just ask... Okay. Yeah, okay. And is it for over a crop, or it's over pasture, or? Great. Yeah. Excellent. So that was a comment there around using the mapping to go into the tractor guidance system to do precision ag work. So that's the other great thing that I perhaps mentioned yesterday, is that these maps are georeferenced. You can create shape files from them, which then can go into machinery, whether it's variable rate fertiliser application, whether it's precision herbicide application, the machine comes on and off. You can have different chemicals within the machine. So there's a whole range of things that are built on the spatial data that come from the drone. So first off, I'm surprised how few people have got the drone technology, but my last statement would be, it's a really easy technology to interact with, and it's quite low cost. And I think most of you would be very surprised about the multiple and manifold benefits that you'll get from it. So that's it. Thank you very much.